Hi guys, and welcome to another week of math. This week we only have one lesson on video because I'm going to go over the volume formulas that you'll use for the entire week in this one video. So you can stop it and take note of the time on that the video's been playing, and then when you go to the next thing, then you can hit play again or look up the video and just move it to that time spot so that you can start it there. Or you can watch the whole thing. You could watch the whole thing a couple of times. It doesn't really matter. Sometimes these can be confusing, but I think if you follow the steps that I give you, it will be a lot easier. I'm letting you use calculators, so that takes away that added stress of getting the arithmetic correct. More focused right now on you understanding just the concept of what volume is, because perimeter and area and volume are very practical things to use in life, in lots of different projects that you do around your house, or depending on what you do for a living, it can be very helpful. So like my parents have a hardware store, and so my mom has people come in all the time and they want to know how much paint to buy, and so she can explain to them how much square footage a gallon of paint will cover. Or if somebody wants to get a specific amount of concrete to pour, and they sell those bags of ready-made concrete mix that you just add water to, she has a formula that she uses, and she can do it so fast, but she can figure out how much they need to fill the space that they're filling. And sometimes that's like for a post hole, and so that might be like a cylindrical hole in the ground that's dug, and so she can help them figure out how many square feet of product they're going to need so that they can buy the right amount of dry product. She does it with roofing too. My dad does lots of area math and perimeter math because he does the bidding for lots of, like, somebody will bring in their house plans or their shop plans, and he will go through and figure out what materials are needed and how much of all the materials are needed to give them a price on what the materials will cost. So I realize those are all like kind of construction building things, but a lot of the times they're just ordinary people coming in doing things for their own homes. So you may not use it in a job, but I think that this is something that's really practical to understand the concept of. So to begin with, when we're talking about volume, okay, we've talked about perimeter. So perimeter is the distance around something. It's a linear measurement. I can say I want, 5 feet of trim, and somebody can give me a stick that's 5 feet long that I can put up, on a window or whatever I'm trimming. If you are getting flooring, you use area, you use square amounts, and you want to buy a square foot of flooring or a square yard of flooring. And so you're measuring by squares, by flat 2-dimensional amounts. Volume is a 3-dimensional amount. So if you look at my cube here, it's a die, obviously. Did you know that? It's die, not dice. Dice is plural, kind of like mice is plural, but one of these is not a douse. I didn't make it up. So this is a cube. We're going to pretend it's just a plain cube so we're not distracted by it. And it's about a centimeter. Each line is about a centimeter. And so this is like a cubic centimeter. So I could figure out how many of these fill up a shape, and then I would know how many cubic centimeters of volume that figure has. So like I have this game called Goat Lords. It's a pretty funny game. It's a card game, but I could take this and figure out how many cubic, if I had a lot of dice, I could empty the box. I could fill it with the dice and see how many cubic centimeters go in there. Or I can take and measure the length of the box and the width of the box and the height of the box and multiply those numbers together, and that will give me the area of the whole box. The other easy thing to remember when we're doing volume of prisms, so we're doing prisms today. So remember, those are objects that have bases and then straight sides in between those two bases. And that's what makes it a prism. So a cylinder is like a prism because it has, the bases are circles and you have this straight in between connecting those two identical circles. And a triangular prism has triangles on the end. So when we talk about the height of any of these things, we're talking about the distance between the bases. So because I could have my triangular prism set like this, and when I talk about its height, that's not the same thing as the height here. When we say height of the prism, we mean the distance between the bases. Okay, so this is the height of my triangular prism. So if I find the area of the triangle and multiply it by the height, that will give me the volume for the triangular prism. And if I take my cylinder and I measure and find the area of the circle on top and multiply it by the height of the cylinder, that will give me the volume of the cylinder. And the same thing for the rectangular prism. The rectangular prism is different though because you can pick many different bases. So I could have these two sides be the bases and then this is the height. Or I could have these two be the bases and this is the height. That's why with a rectangular prism, it's easier just to multiply the three amounts, the base, the length and the width and the height, rather than doing the other. But it's the same thing. If you know the area of the base and you know the height, then you can find the volume of any prism figure. Okay, so let's do some examples. Okay, so I wrote that up here. This is the big picture formula. For the volume of any prism, it's the area of the base, using whatever area formula you need, times the height of the prism. And so we talked about that's the distance between the two bases. That is really important. So the area, and the area is the area of one base only, because we're finding the area of the circle and then we're multiplying it by the height. So the area of the base times the height. And the height is between the two bases. Okay. So a rectangular prism is pretty easy because I find, and on your paper, I even wrote this out like this. So you have spots to fill in. So you can write these things in. The length times the width times the height. Okay, so my length is 30 feet. And it doesn't matter what you call the length or the width. It doesn't really matter. My width is 21 and my height is 13. But if this box were turned this way, I could look at it differently and say that it was 13 wide and that my length is 21 and my height is 30. It doesn't matter because we're just multiplying. The order doesn't matter when we multiply, remember? And so on your calculator, you can multiply. So I have my calculator up on the screen. Times 21 times 13. So this is 8,190. And then really important, you have to put your units. So my units are cubic feet. So you can write that like that. Feet with the little 3. That's because it's 3-dimensional. Okay, it's because we're taking feet times feet times feet. And when I do that, that gives me a cubic foot that I'm measuring. So I'm not measuring 8,190 feet. You know, this measures a foot, my ruler. I'm talking about a cube. That's 1 foot by 1 foot by 1 foot. That's like here, if this was in here, this little cube, that means I would need 8,190 square boxes to fill that shape. Okay. And on some of your problems, you might have like a decimal. Doesn't matter. Do it like normal. You can use your calculator, so don't let it be scary. Okay, triangular prisms. So, sorry, your first assignment is all on rectangular prisms. Low, Gray. Stop. So, this should be, hey, Patty, can you take him to your room, please?
No. Here.
To my room? Thank you. That would be perfect. Sorry. He sees something outside. It's very exciting. Sometimes he's barking at Mr. or Mrs. Rogers walking down the road, but today I don't see anything out there. Okay, so your whole first page is on rectangular prisms, just different kinds. It shouldn't be too bad. Just pay attention to what you're doing. If you are given the volume and two of the amounts, you can find the third amount pretty easily. So I'm going to talk about that here quickly just so that you know what to do. So if I tell you that the volume of a box is 8,190 cubic feet, if I tell you that, and I tell you that the length of the box is 30 feet and the width of the box is 21 feet, and I ask you to find the height, you're going to take the volume and you're going to divide it by the length times the width. Okay, because remember that length times width times height is the volume. And so the volume can be divided by those other units to find the other one. They can be divided by those other side lengths. So if you take the length times the width, take the two small numbers you know, multiply them together, and you're going to divide, do the volume divided by that. So you would do 8,190 divided by, I'll clear this, 8190, let's multiply those, 30 times 21 is 630. So 8190 divided by 630 is 13. So 13 feet. And look, that makes sense because that's what my other side length was. That's what my height was. Okay. Triangular prisms. Okay, that goes to your next page. The other 3D figures, we have these two on there. So the volume of a prism, a triangular prism, would be the area of the triangle times the height of the prism. Okay, so the volume is going to be 1/2 times the base of the triangle, which is 4, times the height of the triangle, which is 5, times the height of the prism. Remember, that's the distance between the bases. That's 10. So I purposefully laid this one on its side so that you could look at what the height means. The height is the distance between the bases. Okay. This one I can do in my head without a calculator, but you can use a calculator if you want. Half of 4, remember half times means half of. Half of 4 is 2. Okay. 2 times 5 is 10. And 10 times 10 is 100. So this is 100 centimeters cubed. 100 cubic centimeters. Okay, cylinder. The volume of a cylinder is the area of the circle times the height of the cylinder. So the area of a circle is pi r squared. And then we're going to multiply that by the height of the cylinder. So I'm going to do 3.14 times the radius squared is 10 squared times the height of the cylinder, which is 25. Remember, it doesn't matter how the cylinder is oriented. The height is the distance between the bases. Okay, so I will do this on the calculator here. 3.14 times 10 times 10 times 25 is 7,850. This is inches, so it's inches cubed, cubic inches. So that's the volume of my cylinder. Okay, so you do those all the same. 3.14 times the radius, because that's what squared means, times the height. Okay, cubes are even simpler. So you have a page that does a lot of stuff with cubes. That's from your book. I made the other two worksheets for you to do this week because sometimes the book has a little too much clutter for doing it home as easily, I think, as doing it in school. So this one is one from the book, so it has a lot more to it. It's optional, but I suggest that you try it because it's good practice. But it has a lot of stuff with cubes. Cubes are easy because all you have to do is take the length of one side and multiply it by itself 3 times. Okay, you just cube it. That's what makes it a cube. You cube it. All the sides are the same. And so that makes it a lot simpler. Okay, same thing with your units. Your units are always going to be cubed when you have volume. So volume always equals units cubed. Always. Because you're doing a unit times a unit times a unit. So you have 3 dimensions for that unit. Length and height and width. Okay? All right, I hope you have fun with that. Now, I like doing this because it feels methodical to me, so I'm hoping that you do too. So have a good week with math. Come back to this video anytime you need to and check on the things that you're working on. Okay? And I will see you next time. Bye.